In the last class, we had discussed about the different micromechanics related concepts related to Coriolis components, related to dynamics of a system, related to torsion of the beam. We have also discussed about the Poisson effect. So we have also discussed about the negative Poisson effect, how negative Poisson effect can be efficiently used in the case of a microrobotic system. Basically, we have taken an auxetic structure as one example. So with reference to this auxetic structure, we have like how a negative Poisson ratio can be demonstrated, and then we had also discussed about this micromechanism, the bending moment arising due to the residual stresses, so which has a direct relevance towards the kind of a biomorph application which we had discussed. Now in today's lecture, so let us discuss about some of the, so whenever we are trying to design this micromechanics system design, so there is a need to understand the design and selection of material for a microrobotic system. So like as we all know, we have seen in the earlier lectures also, the auxetic structure has played a vital role with reference to creation of this negative Poisson ratio. So with reference to this negative Poisson ratio, so if you try to observe, like this negative Poisson ratio is getting generated not only because of the material, but it also depends upon the structure. So the overall, in the case of an auxetic structure, the structure is in the form of a pentagon. So appropriately, when we try to apply a load, there is a kind of an elongation which persists over here. Now in this case, in the case of an auxetic structure, one of the key point which we may need to consider is like not only the material, the overall structural capability as well as the overall manufacturing capability also plays a vital role in fabricating, in giving the functional property based on the requirement. So this is one important point. So as far as when we try to look into the overall classifications or the overall parameters which are involved in the design and selection of a microrobotic system. So like we may need to classify it based on the different challenges, based on the different properties, and with reference to based on the different parameters. Okay, so let us classify the materials for a microrobotic system. So as we all know, a material play an important role in functionality, performance, and durability of the various component of the microrobot. So the selection of the material depends upon the factors. So in the case of key factor in material selection, one is called as a mechanical property. So as far as mechanical property is concerned, we all are well aware about it. So whenever we are trying to design such kind of microrobotic system, there is a kind of so we may need to consider the strength of the system based on the actual functionality, flexibility of the system. In fact, we had also discussed about these flexible structures. So in certain cases, we may need to go for a flexible structures. In certain cases, there is a need to go for a rigid structures based on the requirement. Then we have a toughness which plays a vital role, and the resistance to wear also plays a vital role. So when we try to talk about wear, like in most of the cases, so when we consider an actuator or a sensor or a micro robotic system, so there is a kind of like there is a regular contact of these particular system towards the surfaces or towards the functional characteristics. So what happens is, when there is a continuous contact happen, there is going to be a wear and tear of the system. So appropriately, our surface also needs to be realized to take care of this particular requirement. So this is where exactly the mechanical properties play a vital role. Next, when we try to talk about the electrical and the magnetic properties. So in most of these micro-robotic cases or in the micro-robotic conditions, so we have been discussing about this energy related issues or energy related challenge. So in most of the micro-robotics, so we try to go for a kind of a contactless charging. So appropriately, the material what we are selecting should have a capability. So wherever the material is required, appropriately it should have an electrical characteristics, as well as it should also have an appropriate magnetic characteristics. So when we try to talk about the electric and magnetic properties, so like it should have a good conductor for sensing related applications. And when we try to talk about magnetic material, so these magnetic material can be incorporated into the system for a kind of a remote actuation. Okay, like I will be discussing in the next module, where we will be discussing more on this micro magnetic actuators for micro robotic applications in detail, where we will get a clarity. In fact, there are some case studies where selective magnetic field are applied on these particular structures, so that you can create a kind of a mixed domain to create an appropriate displacement. Okay. Next most important point, like as far as even this we have seen during the application of micro robotic structures, biocompatibility of these structures. So biocompatibility, when we try to talk about biocompatibility, automatically the application of these micro robots comes into the picture. Based on the applications, appropriately we may need to look into the biocompatibility of it. So in the case of biocompatibility, so if we consider it as a medical applications, it might be more towards drug delivery, towards surgery, etc. In the case of other applications like non-toxic and non-reactive based systems can also be deployed. Most important point is with reference to ease of manufacturing. So whatever smart materials or whatever like a micro robotic system which we are planning, it should have a kind of overall, it should gets well adapted within the process of microfabrication, so that these microfabrication has an is efficient enough to fabricate such kind of structures what we are looking for. So these manufacturable with microfabrication techniques such as lithography, 3D printing, micro etching, chemical etching, etc., which we will be discussing, so will also play a vital role towards this particular process or application. In fact, we will be having a detailed lecture on the different microfabrication techniques which are available, and we will also be discussing about a concept of micro 3D printing in detail. Then we need to talk about this environmental sustainability. So in today's conditions, environmental sustainability play a vital role with reference to manufacturing, or with reference to material selection, or with reference to a system design, etc. So as far as environmental sustainability is concerned, so one of the important aspect is kind of a corrosion resistance of the structure. Second, it should bear a thermal change, and it should also able to bear a chemical degradation. So this is one important point which we may need to consider with reference to the environmental system. Overall, so when we try to consider the key factors for material selection of micro robotic systems, these are the key factors which contributes to the overall systems. Now, considering the factors which we have discussed earlier, these materials has been utilized for different applications of micro robot. One is with reference to structural material. Let us take the weight. So the material used for the frame and the body construction should be of lightweight, and it should have a capability to reduce the energy consumption and facilitate fast motion. In fact, propulsion in a micro robotic system is one of the key aspects which we may need to consider. So in the case of so when we try to consider a propulsion, so appropriately the overall body construction and the lightweight will also come into the picture for the effective propulsion or the effective micro manipulation. Next important point is with reference to strength to weight ratio. So for the given weight, the frame, the material should have a strength to bear the additional components, basically the payloads what we are working upon, as well as it should also have a capability to maneuver with the available load or available onboard systems which is being deployed over here. Like for example, so if we are developing a small micro robot for biomedical applications, so there is a need to carry a kind of a drug along with it, so that it is whenever it is used for a drug delivery application. So here the strength to weight ratio will play a vital role in such a way that the payload characteristics as well as the carrying capability as well as the propulsion of the system will also comes into the picture. Next, when we try to talk about the corrosion resistance, it should withstand a varying operation condition for a longer period, which we normally call it as a reliable system. So at different conditions, normally it is required, it is mandatory to look into the overall operation condition capabilities at different simulated conditions. Either it might be used in biomedical applications, or sometime it may be used in surveillance applications. In case of oceanography, it has its own advantages, etc. Next, when we try to look into the manufacturing capability, it should be easy to manufacture. Like as I had mentioned earlier, like whenever we are trying to fabricate these structures, so these fabrication is based upon either on the top down approach or on the bottom up approach. In fact, we will be discussing more about this bottom up approach and top down approach. So either it should be a kind of a bottom up approach, or it should have a top down approach, or it should have a combination of both for an efficient manufacturing of these micro robotic systems. Now let us see some of the structural materials which are efficiently being deployed for these micro robotic related applications. So if we closely observe these different structural material, one of the key structural material which is used in micro robotics or any MEMS based structure is silicon. Of course, silicon is considered to be a dominant material for MEMS and microstructures as well as microsensors, etc. And these MEMS based rigid structures are quite efficient enough to handle these micro robotic structures on the system. Then when we try to talk about the other materials, one is a kind of a polymer. So there are different types of polymers which exist, which includes the parylene, PDMS, polydimethoxysilane, which we call it as PDMS. So we can also have a PET kind of structures, polyamide structures which exists. These kind of PET and polyamide structures are efficiently used as a kind of a substrate. In fact, in our micromechanic systems also, we have discussed about the Kapton polyamide, which is used for biomorph actuation related applications. So in those conditions, wherever we are trying to talk about a soft micro robot or a kind of a flexible systems or soft robots or flexible structures, wearable structures, etc., these polymer structures will try to efficiently contribute towards the behavior as well as towards the characteristics. Next, when we try to talk about a shape memory alloy comes under the category of smart materials. So these shape memory alloy, along with shape memory alloy, there are different other smart materials which also contributes to this particular system. So like we have a thermal actuator in place, and then there is a flexible micro robots in place. Then one of the other material which basically, like we have also seen the kind of an electrical characterization which also participate. So with reference to this electrical characterization, if you see, so there is a need to incorporate certain amount of metal interconnects into the system. So when we try to closely observe this metal interconnects, so these metals basically includes like Al, NiPt, Au, etc. So these acts as a interconnects, or these acts as a electrodes for the circuits. Okay. Next, we have a hydrogels. So as far as these hydrogels are concerned, so these hydrogels has a kind of a potential application in the case of soft robotic system. So like it's a kind of a semi-liquid layer or a semi-fluid layer which has a capability to induce a certain amount of compression on the structures, and with reference to the compression we can have a kind of an actuation or a kind of a force which can be exerted by these hydrogels. Nowadays hydrogel based actuators are efficiently used for different biomedical related applications. Then we have a graphene and a carbon nanotube which is available. These graphene and a carbon nanotube has a potential application towards sensors and energy storage related applications, and which has a direct relevance towards the functionality. Now let us discuss about the actuator material. So as far as an actuator material is concerned, so like we had seen a lot. So to give you a kind of a recap, what do you mean by an actuator? So an actuator is a system or a device where we can have a different type of input, but our output will be in terms of displacement. So this displacement can be either a mechanical displacement, or it might be a kind of an electromechanical system, or it might be a pneumatic or a hydraulic system, etc. Now when we try to talk about these kind of actuators for a micro robotic system, we need to consider certain parameters which will fit into the requirement of a microrobotics or to cater the functionality of the microrobotics and application of microrobotic systems for different applications. One of the important parameter is the energy efficiency. So, the actuator material should have a high energy efficiency to reduce power consumption and work for a longer period of time with limited power supply. So that, like for instance, when we are trying to use a kind of a simple micro robot for a kind of a drug delivery related applications, etc. So when we try to inject it in a body, so this will reach a particular point and then it will disperse the drug. Now till that time, so either we can go for a non-contact based actuation, or if we are having an onboard energy system, so these energy systems should be capable enough in such a way that it reaches a particular point and it tries to deliver the functionality of it. This is one of the key parameter which we may need to consider. Next with reference to actuator is concerned is the force to weight ratio. So the material required for actuator should provide a high force with a light weight as possible for an actuator. This improves energy efficiency and also it provides better locomotion. So as far as this force to weight ratio is concerned, with reference to micro robotic perspective point of view, like most of our systems which we are using it for micro robotic application will fall under the category of either thin films, or it might be a nanomaterials, or sometime it might be a kind of an integrated material. So this thin films will be appropriately embedded into the structure to get an actuation, and nanomaterials can be embedded into the structure, like you might have heard about this concept called ferrofluids. So these ferrofluid based structures, it is a kind of a nanomaterial which is being integrated or dispersed inside the liquid medium, and these liquid mediums are being actuated with the magnetic field and finally it tries to take a shape. Okay, and then an integrated system is something like this. We can have a kind of a coil which is being present over here. So with reference to the coil, when we try to apply a kind of a magnetic field, there is going to be an actuation which exhibits, and based on this actuation we can study the overall deflection studies what we are looking for. Next is the high flexibility is required in the case of a soft robotics. Most importantly, it should have a kind of capability or a realization towards biomimicking robot. So that is one of the important key parameter which we may need to consider with reference to flexibility in the system. Now there are different types of actuator materials are there which is highly contributing towards the micro robotic applications, especially on a micron level as well as on a nano level. Now if we try to closely observe the different types of such kind of actuator material, so one of the actuator material which is efficiently used is called as a piezoelectric material. So if we try to look into the overall classification of the piezoelectric material, it is either termed as PZT or PVDF. So PZT is slightly not efficiently used today because of the lead content which is available. However, PVDF is efficiently used. In lieu of piezoelectric, there are certain materials which are taking up a new shape, which we call it as triboelectric nano generators. So the main functionality of this triboelectric nano generators are like, we might have heard about this concept called electrostatic charge. So that is whenever we try to wear a woolen cloth and when we try to remove it during a winter season, so we hear a kind of a spark which tries to get generated out of it. This spark is generated because of triboelectric behavior, which is nothing but a kind of a either a contact separation or a kind of a sliding which exhibits with reference to two different material. One is called as a tribopositive and the other one is called as a tribonegative. When these two charges rub, and then appropriately a spark is generated, and these sparks can be efficiently used. Now, like this system is a kind of is considered to be an alternative for a piezoelectric structure. So in the case of a piezoelectric structure, we talk about a kind of a crystal, and when we try to apply a load to it, we get a biasing, and similarly when you try to apply a biasing, we get a kind of an actuation which persists. However, in the case of a triboelectric, so where we will be having a contact mode as well as a separation mode. With reference to the contact and the separation, there is going to be a charge transfer, and from the charge transfer we can efficiently see the overall characteristics as well as the overall diffusion of the charge, which is capable enough and which can be vented appropriately. Okay, so like not only as a precision actuator, so these piezoelectric and triboelectric structures are efficiently used for sensing related applications also. However, triboelectric perspective point of view, it is more focused towards sensing. However, piezoelectric perspective point of view, it is more focused towards the precision actuator. We will be discussing about this in detail in the upcoming modules about the overall configuration of piezoelectric materials and piezoelectric actuator, how these piezoelectric materials and piezoelectric actuators are being efficiently deployed for micro robotic related application. Next one, we can also call it as a magnetostructive material or magnetic based materials. So like piezoelectric material, so magnetostructive material also works almost in the similar principle, that is like when we try to supply a magnetic field to it, so there will be a kind of an actuation which exhibits. However, vice versa, when we try to supply a load, we can have a magnetic field which will be generated out of it. So terphenol D is a kind of a standard material which is used for such kind of magnetic magnetostructive materials. In fact, as far as magnetic micro robots are concerned, apart from this, there are other wide varieties of magnetic materials which are being exhibited. So like neodymium based magnets, paramagnetic magnets, ferromagnetic magnets are also available. These paramagnetic magnets and ferromagnetic magnets can be efficiently used for actuation related applications. Next, when we try to talk about shape memory alloys, so shape memory alloys like either it might be nickel titanium or it might be copper based shape memory alloys. So commercially, when we try to look into these shape memory alloys, these shape memory alloys are either available in wire form or in powder form, wire form, powder form, sheet form or spring form. So, but however, for a micro robotic perspective point of view, we may need to tailor these shape memory alloys based on the requirement or based on the application perspective point of view. So, there is a need to focus upon a certain shape memory alloy structures, like or to manipulate these shape memory alloy structures based on its capability or based on its functionality. So that's how we have come up with the bimorph. We can also go for a micro 3D printing of the shape memory alloy structures for micro robotic applications. Okay. So if you closely observe these shape memory alloys, so it basically depends upon the overall actuation condition. So based on the actuation condition, so appropriately we try to classify this shape memory alloy structure. So like if we have a working window in the range of like 80 to 130 degrees Celsius, ideally we go for nickel titanium based shape memory alloy structures. In certain cases, if we have a range of 250 to 350 degrees Celsius, we go for a copper based shape memory alloy structures. Next important material is called as an electroactive polymer. So these electroactive polymers are efficiently, which we call it as polypyrrole. So these electroactive polymers are efficiently used for a kind of artificial muscle generation or soft robotic related structure generations, etc. So by appropriately incorporating these electroactive polymers, so we get a kind of a flexible actuator which exhibits, and these flexible actuators are efficient enough for to create certain amount of actuations. Next, there are certain amount of flexible structures like liquid metals. It's a kind of a gallium based alloy. So these has a potential application in the case of reconfigurable circuits as well as soft robotic related applications. So in fact, it has a wider spectrum with reference to the reconfiguration and soft robotic related applications. Now, when we try to talk about the sensor element, so what is a sensor? So sensor is a device. Ideally, it has a kind of a sensing element and a transduction element. What is this sensing element and what is this transduction element? Okay, let us take a simple thermocouple or a simple thermometer. So, in the case of a thermometer, so we have there is a mercury which is available, which is used for sensing the temperature, and a graduation over here. So, what happens is there is a kind of a liquid. So, these liquids, when it gets heated up, or if you want to measure the temperature of this liquid, when the mercury is immersed in it, so this mercury will try to expand, and this expansion is marked or it is identified in this graduated readings. Okay. So, this expansion of this mercury is like here mercury acts as a sensing element. So, it senses the temperature, and then we have a kind of a transduction element which will try to what you call manipulate this overall expansion in the form of a gradient. So, ideally the transduction element will be helpful for us to translate the overall variation which is happening in the sensing element, and we can see like it is a kind of converting one set of parameter into another set of parameter to study the behavior of the system. Like as far as in this as far as the sensor material are concerned, so the sensor materials are basically focus upon three different parameters, especially for micro robotic related applications. So, these sensor materials should have a highly towards the minute change in the environment, such as force, high pressure, temperature, chemical and fluid flow. As far as miniaturization perspective point of view, for the desired sensitivity, the sensor should be small enough to be integrated on the micro robotic structure. So, which earlier also we were talking about the payload. So, in most of the cases, like when we try to consider it as a system, these sensors should be capable enough in such a way that it can be integrated with the system, and appropriately when we try to actuate it. So, we can when we try to use it in the system, it should not be a burden to the system, however, it should complement to the system. Third important parameter is with reference to the minimal power to ensure longer operation. So, power consumptions play a vital role with reference to these sensing systems, so that appropriate characteristics can be deployed and the overall characteristics can be studied in detail. Now, let us discuss about the different sensor elements. So, as far as these sensing element is concerned, so if it is something like based on the application, we can select the sensing element. So, one of the application includes the chemical reduction. So, with reference to chemical reduction, we have a graphene and a carbon nanotube in place. As far as biosensing perspective points of view, so we have biosensing and pressure and acceleration sensing. So, there is a silicon based structures are being evolved. So, like in a simple term, we had discussed about this cantilever operation, we have discussed about this serpentine operations, we have also discussed about this kind of a beam based operations. In all these conditions, wherever a silicon can be deployed, so the silicon has a capability to get actuate, and then appropriately it will be translated based on the requirement. Next, when we try to talk about a vibration sensing, so we have discussed a lot about this before also, like piezoelectric material and triboelectric materials are considered to be a promising materials towards vibration sensing related applications. Now, when we try to talk about a biosensor for medical biorobotics, so these biocompatible polymers play a vital role. So, when we have these biocompatible polymers, see these biocompatible polymers are capable enough in such a way that it can be deployed for different applications as well as different characteristics. Now, like in most of these cases, so it is something like sensor materials. Here we are talking about the sensor materials and we are not incorporating any kind of transaction material in this. Okay. However, in most of the cases, these sensor materials are well incorporated with the transaction materials appropriately, so that we can have a kind of an efficient transformation what we are looking for. Okay. Now, let us discuss about the power source materials. So as far as these power source materials are concerned, so we have seen over here, like these in the case of a micro robotic system, it is always expected that either we should have a kind of a charging or a recharging capability, or we should have a kind of a process in which where we can have a kind of a non-contact based charging which can be deployed over here. So appropriately having a non-contact charging will be helpful for us to actuate it at localized domain or in the case of a specialized domain. So when we try to talk about this power source material, so like energy density play a vital role. So the material should have a high energy density to provide a longer operation life cycle. So which is something like when in an actual operation or in an actual field, so these micro robotics in most of the cases it becomes like after a particular time it will either be kept a standalone. So in those conditions it is always the overall energy density is restricted for a particular period or a particular requirement. So in those conditions the material what we are selecting should have a kind of a high energy density so that it can power up the system for a longer operation. Second important parameter is with respect to charging and recharging capability. So the power source should have a capacity to go for a fast charge, and it should be rechargeable. Like there are certain applications where magnetic systems are used for charging applications. In certain applications there are also systems where kind of electrostatic systems are used for charging and discharging. In certain cases where we can also use a kind of a thermoelectric based systems, so which can be used for charging of the system. Next, as far as weight and flexibility is concerned, the material should be lightweight and flexible enough to integrate with a micro robotic structures what we are looking for. So we will discuss the different types of material which can be deployed for power source materials in the upcoming classes. Thank you.